You're heading up a robotics, very exciting robotics project here at Sydney University. Can you give us a definition of robotics?
Robotics is about intelligent machinery, or the instantiation, I guess, of artificial intelligence. It's all about taking a mechanical platform, a mechanical electronic platform of some sort, and then adding levels of intelligence into it.
Robotics been a childhood dream of yours? Have you been long interested in it?
Oh yeah, it's about 20 years now I've been working in the area. I guess I've always been interested in the mechanical and the electronics coming together. When I started my engineering degree, there was no such thing as robotics. It was more about mechatronics, and that slowly transitioned to the robotics area.
Why should Australian farmers be excited about robotics?
The standard process of where robots will offer things in efficiency in operation, and generally we term them where robots become really useful is in the dull, dirty and dangerous areas. So whether it's a dull job, or whether it's a dirty job, or whether it's a dangerous job, then robotics come into play there, and they have the most benefit in those areas. Farmers have been interested mainly in I guess there are many technology pools at the moment now through the farming industry due to things such as labour shortages, finding the right people at the right time for harvesting in particular, the ageing population of the farmer, so not many young people going back into the farm. So because of that, and stiff competition from overseas, they're looking for ways in terms of improving efficiency on the farm, and robotics offers that opportunity, or one of those opportunities.
So you're heading up what sounds like a very exciting trial program involving an orchard at Mildura and another trial in Melbourne. Mm-hmm. Can you tell us a bit about what you're doing?
So this project was funded through Horticulture Australia as well as the Australian Centre for Field Robotics at the University of Sydney. The project involves taking a robotic platform that has many different types of sensors on board: vision sensors, radar sensors, laser sensors, thermal sensors and hyperspectral sensors, and having them go up and down tree orchard farms and being able to collect information about the tree and the fruit, and do things such as in real time estimate the volume of individual trees, the health of trees, calculate how much fruit is on the tree itself, and then potentially going to the point where we're classifying the ripeness of the fruit as well.
That sounds fantastic. What about robotic harvesting? I mean, that's going to be particularly in the fruit scenario.
Yeah, and that's the end game, is to be able to sit down and not only predict the health and the yield count of the tree crop, but also at the end of the day being able to do some sort of mechanism, harvesting mechanism. And that will come down to the type of fruit variety. So in some applications it'll be quite easy. So in the nut industry, for example, where you can shake a tree and just sweep up the nuts, it's going to be a relatively easy task to take tractors that you currently have now and automating them in some form. In other industries such as like the apples or the grapes or the soft fruit, for example, it's going to be a little bit harder, because to do something there you need to be able to manipulate and get to the fruit, and have some sort of manipulator and get to the fruit and handle the fruit. And to get something as soft and as dexterous as a human arm is quite difficult at this point in time.
When do you see robotics making a significant contribution to the productivity of farmers of all sorts?
Well, if we look about broadacre, you're already seeing that now.
Yeah.
Okay. And so the question is, how do we take that into the other areas of the farming industry? Tree crop applications will be easier than, say, the vegetables and so forth, where it's a lot harder. You have different farms, different ways of being able to grow these vegetables, and so taking a single robot that can work on different farms, even if the same type of vegetable crop, is going to be a difficult problem. Within the tree crop industry, my feeling is within the next couple of years we're going to see a lot of these systems that we're developing now going into commercial reality. Whether they're the robots themselves, they may not end up being the robots that we've developed here, because with the way we develop is more on the prototype side. But you can imagine the sensors and the algorithms and the computers being able to transition off our robot into autonomous tractors that will be able to go up and down tree within a couple of years and do things such as monitoring of the tree and yield count and understanding fruit ripeness and so forth. Harvesting, as I was mentioning before, will come down to the individual tree variety. If I go to any one of the nut industries where they already use current, shakers and so forth, it'll be a relatively simple task to automate one of those processes. So within a couple of years, I would see in some industries the process of being able to do yield estimates and fruit ripeness. Within the 5-year, you'll start to see more autonomous harvesting systems.
What's the schedule for the trial program that you're running now? How many people have you got working on it? Is it a big budget kind of trial?
It's a relatively, compared to, I mean, at our institute here, we have projects within the mining industry, stevedoring industry, defence industry, commercial aviation, and they're much larger projects that happen, that are happening there. What's nice is that a lot of the technology that's being developed in those sectors is transferable across into the farming industry. So it doesn't require major investment amongst the farming industry to kind of get these things prototyped and set up and demonstrated on a farm site. There are 6 people working on the project, mechanical, electronic engineers, as well as research fellows who are working on machine learning algorithms and classification algorithms to be able to detect fruit and the yield of the fruit, the ripeness of the fruit. And the schedule is that every year we have 2 visits to Mildura and 2 visits down to Melbourne. We're looking at almond farms and apple farms and looking at how the algorithms will work on those 2 different types of tree crops. Because using those 2 types of tree crops, it'll be easily transferable into similar types of tree crops in the other industries. The program runs over 2 years, another 2 years, and by the end of the project, we will have a set of algorithms and sensors that will be ready to be implemented onto farms.